the invisible shield that protects us. Imagine an Earth without a magnetic field, without protection from the solar wind, without a compass, without stable navigation. What if one day it disappeared or started behaving unpredictably? Every year, scientists record anomalies more and more often. The South Atlantic anomaly is expanding. The northern magnetic pole is rapidly drifting towards Siberia, and the field strength is decreasing. What is this, the beginning of a geomagnetic inversion or something completely new? The Earth's magnetic field is one of the most mysterious and important components of our planet. It is invisible, but vital. In this video, we take a fascinating journey deep into the Earth's core to understand. How is the Earth's magnetic field formed? Why is it weakening, and what is the South Atlantic anomaly? Is a pole shift possible in the near future? What will happen to mankind if the magnetic field disappears? Fasten your seat belts. We begin our dive into the deepest and most mysterious processes that shape our world. How does the Earth's magnetic field work? The magnetic field is created by geodynamo, the movement of molten iron in the Earth's outer core. These movements create electric currents, and the currents in turn generate a magnetic field. It extends far beyond the planet, forming the so-called magnetosphere, an invisible cocoon that protects us from the solar wind and cosmic radiation. Interestingly, the magnetic field is constantly fluctuating. It strengthens and weakens, changes shape, and even flips over. Scientific data confirms that magnetic inversions have already occurred in the Earth's history, when the North and South poles changed places. What is happening to the field today? Over the last 200 years, the strength of the magnetic field has decreased by about 9%. That's not just a statistic, it's a troubling symptom. Scientists are particularly concerned about the South Atlantic anomaly, an area over South America and the South Atlantic where the magnetic field is particularly weakened. It is in this region that satellites fell more often and the radiation impact on them increases. Some scientists believe this is a sign of an inversion that has begun. Others say it's a temporary anomaly. But a growing body of evidence suggests the magnetic field is behaving erratically, and the consequences could be serious. The poles are on the move. The magnetic North Pole, which was still in Canada at the beginning of the 20th century, is now rapidly moving towards Siberia. Its speed has more than tripled from 15 km or year to 50-60 km or year. Scientists from the U.S. Geological Survey and the Alvin Institute of Geophysics are watching this process with alarm. Such a shift could affect navigation systems, aviation, satellites, animal migrations, and even climate. And if the inversion really begins, we will be witnessing a grand but dangerous phenomenon. New alarming signals. The Earth's magnetic field, which for billions of years has protected life from cosmic aggression, is now beginning to behave strangely. Scientists from around the world are watching this process with alarm. Back in 2020, satellites of the European Space Agency's Swarm mission recorded serious deviations in the structure of the field. A particularly mysterious zone is the South Atlantic anomaly. Here, the magnetic field is weakened so much that spacecraft literally sag in their defense. Some of them even fail because of the increased flow of radiation. It's been called the Earth's weak spot. But what is even more surprising within this anomaly began to form a second point of minimum. That is, the area where the field practically disappears. This could be a sign that a geomagnetic inversion is not just possible, but has already begun. Pole drift, an acceleration not expected. The North Magnetic Pole is leaving Canada and rushing towards Siberia at a speed of up to 60 kilometers per year. For comparison, at the beginning of the exact century, its speed was only 15 kilometers per year. This process has accelerated so much that international services had to urgently update navigation maps and programs. But why is this happening? The magnetic field is created deep underground in the outer core, where liquid iron and nickel form giant currents. When those currents change, the magnetic field changes. And since we cannot look there directly, all that we see, this is only the surface manifestations of much deeper and still incomprehensible processes. The pole shift is already affecting aviation, navigation, and even the migration routes of animals. Some species of birds and sea creatures are losing their orientation. This may seem like a small thing, but at the level of the biosphere, it is a wake-up call. What if the magnetic field disappears? The complete disappearance of the Earth's magnetic field is a rare but theoretically possible scenario. Although in practice, it would likely just weaken greatly, the consequences of even a temporary disappearance would be catastrophic. Let's imagine there is no longer any magnetic shielding on the Earth's surface. What's in store for us? Radiation shock. Solar wind and cosmic radiation reach the surface unhindered. Ordinary magnetic storms become deadly. This leads to an increase in cancer, mutations in DNA, massive reproductive failures in animals and humans, collapse of satellite systems, navigation, meteorology, internet, military systems all operate through satellites. In the absence of a field, electronics overheat, atmospheric ionization increases, and satellites fail one by one. Power problems. Magnetic storms are already capable of causing power grid failures. If there is a strong inversion or the field weakens by a few percent, the consequences could include nationwide power outages, transformers failing, communications and internet outages, climate fluctuations. Although a direct link between the field and climate has not yet been proven, there is evidence that dramatic changes in temperature patterns and air mass circulation have occurred during past inversions. Psychophysiological impact. Some scientists and alternative researchers claim that the magnetic field affects brain rhythms, biorhythms, mood, and even time perception. When the field is weakened, anxiety, sleep disorders, and depression can increase. It's happened before. The history of geomagnetic inversions. Magnetic field inversions are not science fiction. They are a documented geophysical fact. Over the past 20 million years, the Earth's polarity has reversed more than 80 times. The last major inversion, the Bruns-Matsuyama inversion, occurred about 780,000 years ago. Then the north and south magnetic poles literally switched places. The transition took several thousand years. But there were also faster, shorter-term events, geomagnetic excursions. For example, the Lecampa event about 41,000 years ago lasted only a few hundred years. The field intensity dropped to almost 5% of normal. What's interesting, this event coincides with a number of climate anomalies and the extinction of some species. Some scientists even believe that this is when Neanderthals began to disappear, giving way to Homo sapiens. Humanity survived. But back then, it was not technologically dependent on power grids and satellites. Today, the situation is quite different. Magnetic field and technology on the verge of failure. Modern civilization means thousands of satellites, millions of kilometers of cables, sophisticated navigation and communication systems. All of this is vulnerable. Even a slight weakening of the magnetic field can cause massive GPS failures, especially in aviation and military applications, affect cell phones and the internet, increase errors in navigators in cars, airplanes, ships, disrupt financial systems and bank servers, endanger astronauts and manned missions into space. Polar regions, where the magnetic field is already weaker, are especially sensitive to these phenomena. It is there that disruptions in satellite communications and failures in electronics are already being recorded. Despite all the warning signs, mankind is already thinking about defense. Scientists, engineers, and international agencies are developing scenarios to adapt to a possible inversion or weakening of the magnetic field. Infrastructure protection. Magnetic shields on satellites. Many satellites are already being equipped with additional radiation shielding. In the future, if the field weakens, such measures will become mandatory. The development of special miniature magnetic fields around satellites is possible. Redirecting satellite orbits. If it is known that the magnetic field is weaker in a particular area, for example, the South Atlantic anomaly, satellites can be reorbited in advance, either temporarily or permanently. Underground storage and backup systems. Underground data centers, shielded from external radiation, are being established to protect critical information, especially government data. Medical adaptation. Magnetically shielded chambers. These technologies can be used in space, in underground laboratories, and in medical centers. The chambers shield against radiation and maintain a stable magnetic environment, which helps reduce stress and physiologic strain. Anti-radiation drugs. Scientists are working on substances that increase the body's resistance to ionizing radiation. This research is funded, among other things, in preparation for future space missions. Scientific monitoring and response. Monitoring networks. Worldwide agencies such as ESA, NASA, and university laboratories monitor geomagnetic activity 24 hours a day, 7 days a week. Rapid warning centers for storms and anomalies are established. Response protocols. Guidelines are being developed for energy companies, airlines, military, and rescue services. In the event of a magnetic anomaly, risks can be mitigated in advance. Shut down sensitive equipment, change routes, limit activities in dangerous regions. Magnetic field and biosphere. We're used to thinking of the magnetic field as something technical, but in fact, it affects the entire biosphere, including animals and possibly even humans. Animal migrations. Many species are oriented by the magnetic field. Birds, geese, pigeons, storks, sea turtles, salmon, bees, even bacteria. They have special cells or molecules in their bodies that are sensitive to the magnetic field. If it changes, animals can go off course, fail to find a breeding ground, or die along the way. Geomagnetic sensitivity in humans. So far, this question is controversial, but some scientists suggest that humans also sense the magnetic field subconsciously. There are hypotheses that changes in the geomagnetic environment can cause headaches and anxiety, sleep disturbances, decreased concentration, spikes in aggression or depression in years of increased solar activity. Heart attacks and traffic accidents are reported to increase. Does the magnetic field affect the climate? Official science has yet to give a direct link between geomagnetic changes and climate change. However, interesting correlations are emerging. During the Lecampa event 41,000 years ago, there were climate anomalies, cooling, and mass extinctions. As the field weakens, the inflow of cosmic radiation increases, which can change cloud cover and hence temperature. The magnetosphere is involved in protecting the atmosphere from ionization, affecting the processes on which the circulation of air and water depends. It is also worth noting that the magnetic field can interact with solar activity, and that, in turn, affects climatic processes on Earth. So far, these are just hypotheses, but more and more scientists are paying attention to them. Alternative hypotheses and mysteries. When it comes to magnetic fields, there are not only scientific theories, but also hypotheses that go beyond academic science. Magnetic field as a carrier of information. Some researchers believe that the field can preserve the fingerprints of evolution. That is, it is not just a protection, but a kind of energy memory of the planet. This idea sounds almost mystical, but finds support in theories about the holographic nature of the universe. Field and consciousness. Supporters of this idea claim, during strong geomagnetic storms, people have more vivid dreams, intuition increases, and unusual states of consciousness arise. There are even studies linking the level of geomagnetic activity with mass moods in society. Cosmic cycles. Some scientists hypothesize that changes in the magnetic field are due to the solar system passing through different parts of the galaxy. For example, through spiral arms where there is a higher density of stars and radiation. This may explain regular geomagnetic inversions and climate crises on the planet. Esoteric versions. In esotericism, there is the notion that the magnetic field restrains higher forms of energy, and its weakening would open a window of opportunity for a new era of consciousness. Such ideas are popular in spiritual circles and futurological theories. The magnetic field is not just a physical phenomenon. It is an invisible shell that has protected life on Earth for centuries. It's a cosmic barrier keeping chaos out of the atmosphere, but today, that shield is faltering. We are witnessing its instability. Perhaps an inversion is coming. Perhaps it's just a temporary anomaly. Science has yet to provide definitive answers. But one thing is certain: all life on this planet depends on this delicate, fragile structure. And the further we advance in technology, the more we realize we're vulnerable to it. Doesn't matter how powerful our computers and rockets become if the magnetic field disappears. The basis for stability disappears. But there is another side to this. We have the brains, the knowledge, and the combined science to not just predict, but to act. We have a chance to not just survive, to adapt and become stronger. Today, we stand on the brink of change. We face not only a challenge, but also an opportunity to better understand how the Earth works, and maybe the whole universe. If you are close to science, if you feel at the greatness of the planet, if you want to know what will happen next, stay with us. There are more mysteries to come. And perhaps the most important discoveries are yet to come.
When we look up at the night sky, stars seem like small points of light. But, of course, this is a deceptive impression. Stars are colossal objects at great distances from us. Particularly interesting are giant stars, such as Betelgeuse and Antares. These giants are kind of living monuments of cosmic evolution, as their incredible size and brightness give us a unique opportunity to study the processes occurring in the late stages of stellar life. Let's delve into the world of these stars and see what they are remarkable for, what are their features, and why they are of such interest to astronomers. Betelgeuse, a star on the verge of explosion. Betelgeuse, located in the constellation of Orion, is one of the most famous giant stars. It is a red supergiant star, about 700 times larger than the Sun. If Betelgeuse were at the center of our solar system, it would engulf the orbit of Mars and possibly even Jupiter. Since Betelgeuse is at the end of its life, its explosion as a supernova is only a matter of time. Betelgeuse features: distance and size. Betelgeuse is located about 640 light-years away from Earth. Its radius is about 764 times that of the Sun, and its mass is 10 to 20 times that of the Sun. Variability and luminosity. Betelgeuse is a variable star, which means that its brightness fluctuates. The reason for these variations is due to internal processes occurring in the star's core. The dying process. Betelgeuse is a red supergiant, indicating that it's in the age stage. It is burning its fuel faster than stars like the Sun and may soon go supernova. When this happens, the star will explode and become one of the brightest objects in the night sky. It will be visible even during the day. This process could happen either tomorrow or in a few tens of thousands of years. Antares, the heart of the scorpion. Antares is another famous giant star that is located in the constellation Scorpius. The name Antares comes from the Greek anti-Ares, which means opposing Mars, as Antares resembles Mars with its reddish hue. This star is a red supergiant, like Betelgeuse, and it is also on the verge of its death. Features of Antares: distance and size. Antares is located about 550 light-years away from us. It is 700 times larger than the Sun, and its luminosity is 10,000 times that of the Sun. Satellite and system. Antares is a binary system, which means it has a companion, Antares B, a hot star of spectral class B. This companion is about 550 astronomical units away from the host star. Evolution. Like Betelgeuse, Antares is in the final stages of its life. Its inner core is shrinking, while its outer layers continue to expand. As with Betelgeuse, Antares has only a short time left before it explodes into a supernova. What is the uniqueness of giant stars? Red supergiants like Betelgeuse and Antares have a special place in astronomy because these stars reach their gigantic size in a very short time by cosmic standards. To better understand their uniqueness, let's look at their life cycle. Stars like Betelgeuse and Antares begin as huge clusters of hydrogen and helium. Due to their enormous fuel supply, they quickly progress to the supergiant stage, burning off the hydrogen in their core and moving on to heavier elements. As such stars burn more and more fuel, they expand to an incredible size, but their core becomes denser and hotter. Eventually, they will reach a stage where they can no longer hold their outer layers together, leading to a huge explosion, a supernova. The explosion of such stars produces not only a bright glow, but also the release of huge amounts of heavy elements such as carbon and oxygen, which then become the building blocks for planets and eventually life. How do giant stars affect the universe? Cosmic pollution. The explosion of supernovae produces heavy elements that are then spread throughout space, replenishing the surrounding space with the material needed to form new stars and planets. Energy contribution. The explosions of giant stars release enormous amounts of energy that affects everything around them. This process triggers new waves of star formation and forms galactic structures. Exploring dark matter and energy. Giant stars and their explosions help scientists explore the fundamental laws of the universe, including the nature of dark matter and energy, which make up about 95% of the mass energy of the universe. Questions to ponder. What are the benefits to humanity of knowing about the structure and evolution of giant stars? How important do you think the role of supernova explosions is in shaping the conditions necessary for life? Conclusion. Studying stars such as Betelgeuse and Antares allows us to better understand not only the processes occurring in space, but also important stages in the evolution of the universe. These giant stars are at a critical point in their lives and are about to explode, bringing enormous changes to the surrounding space. A supernova explosion is not just the destruction of a star, but the birth of new materials from which new planets and possibly life may one day emerge. Giant stars like Betelgeuse and Antares are not just objects for astronomers to study. They are a kind of cosmic beacons that remind us of the incredible scale and dynamics of the universe. When we look at these stars, we literally see the past. The light that reaches us has traveled for hundreds of light years. In fact, the stars may have changed, perhaps even exploded, as their light traveled to us through space. Reflecting on the giant stars, there is a sense of deep connection between all the elements of the universe. After all, everything our planet and ourselves are made of was once inside stars that went through the process of exploding and dispersing their elements into space. Betelgeuse and Antares are living testimonies that even in the brightest and most powerful objects there comes a moment of transformation that leads to new worlds and materials for life. Giant stars also make us think about the temporality of existence. These stars burn brighter than our sun, but because of this they burn faster, passing their life cycle in a matter of millions of years, while our sun will shine for billions of years. Perhaps this is a clear example of the fact that a bright life is not only happiness and success, but also responsibility. After all, giant stars leave important elements for future planets and stars after their death. Observing the processes occurring with such stars, we can feel not only our place in the vast universe, but also realize that each star, planet, even the smallest atom around us has its own story. These stories intertwine to create a truly majestic picture that inspires us to continue to explore and seek answers to questions that humanity has not yet solved.
This shouldn't be happening. The mystery of Comet 29P. Something strange is happening in the outer reaches of our solar system. Just beyond Jupiter's orbit, a single object has been exploding again and again for decades. No warning, no pattern, no clear cause. It brightens by hundreds of times within hours, ejects over 1 million tons of debris, and then falls silent until it happens again. And here's the strangest part. This isn't a comet approaching the sun. It isn't being torn apart by gravity or heat. It's just floating out there in a nearly perfect circular orbit, behaving like nothing else we've ever seen. So what's really happening? Is it alive in some strange geological way? Is there something inside, something we've missed all along? And could this mysterious object be the most active volcanic body in our entire solar system, second only to Jupiter's moon Io? Today, we dive into the mystery of Comet 29P Schwarzmann-Walkman, also known as Centaur 29P. Why does it erupt so violently? And what has the James Webb Space Telescope recently revealed that's forcing scientists to rethink everything we thought we knew about icy bodies in space? Let's find out. The discovery, a centaur among giants. The story begins almost a century ago. In 1927, two astronomers at the Hamburg Observatory, Arnold Schwarzmann and Arno Arthur Walkman, discovered a faint, slow-moving object while comparing photographic plates of the night sky. At first, they thought it was an ordinary short-period comet, but as time passed and its orbit became clearer, the classification changed. 29P wasn't like other comets. It didn't plunge toward the sun in a long elliptical path. Instead, it stayed between the orbits of Jupiter and Neptune, tracing a nearly circular route around the sun every 14.6 years. That placed it in a strange category known as centaur objects named after the mythical half-human, half-horse creatures of Greek legend. And the comparison is fitting. Centaurs are hybrids part asteroid, part comet. They originate in the Kuiper Belt, far beyond Neptune, but gravitational nudges from the giant planets occasionally drag them inward. Once that happens, they become unstable transient visitors to the inner solar system, destined either to fall toward the sun or to be ejected into interstellar space forever. Most centaurs are quiet, frozen, dim, but 29P is something else. It's one of the largest centaurs, known about 60 kilometers across, wider than 96% of its kin, and it's one of the most active objects in the entire solar system. It erupts on average 30 times every year, and 40% of those explosions happen without any warning or pattern whatsoever. No other known comet behaves like this. It's like a cosmic volcano, erupting in the darkness between worlds. The explosive mystery. Each outburst is dramatic. Within just 2 or 3 hours, 29P can become hundreds of times brighter. Sometimes it bursts 4 times in just 2 days. In 2024, it did exactly that, 4 eruptions in 48 hours, making it nearly 300 times brighter than usual. 2 years earlier, it expelled more than 1 million tons of debris into space at supersonic speed. Imagine the most pressurized champagne bottle in the universe being uncorked. And that's not all. Often, one major explosion is followed by 2 smaller ones, about 5 to 7 days later, as if something underground continues to rumble long after the main blast. Astronomers have recorded dozens of these events, but the largest on record happened in September 2021, the most powerful eruption in 40 years. And who first spotted it? Not professional astronomers, but amateurs. Enthusiasts with backyard telescopes saw it flare up before observatories even knew something had happened. That's part of 29P's strange charm. It's unpredictable, and yet so visible that skywatchers across the world can catch it in action. Professional observatories then scramble to study it, fighting for precious telescope time, because who would approve a multi-million-dollar space observatory to watch an object that explodes at random? But sometimes luck is cruel. Just one day before Hubble was scheduled to observe 29P in 2021, it malfunctioned. The telescope went offline, missing the show entirely. Cryovolcanism, the ice volcano theory. So, what causes these outbursts? If you're thinking volcanoes, you're not far off, just not the fiery kind. 29P is what scientists call a cryovolcanic comet, an object covered in ice, with volatile gases like carbon monoxide and carbon dioxide, CO, trapped beneath its surface. Over time, sunlight penetrates the outer shell. It warms the interior just enough to make some of that ice sublimate transform directly from solid to gas. Pressure builds beneath the surface, and eventually, boom, the crust fractures, and jets of icy gas erupt violently into space, carrying dust, frozen water, and other materials with them. That mixture cryomagma is essentially a cocktail of frozen ammonia, water, methane, and nitrogen. It's beautiful and terrifying. Now, you might wonder, why doesn't this happen in all comets? The answer lies in 29P's gravity and rotation. Its escape velocity is relatively high, meaning not all of the ejected debris escapes into space. Much of it falls back, reforming the crust after each eruption, essentially resetting the system for the next explosion. That could explain why smaller eruptions often follow big ones. The surface collapses under its own debris, sealing the cracks, until pressure builds again. A self-repairing cosmic geyser. The circular orbit problem. But there's a problem. Most cryovolcanic comets orbit the Sun in elongated ellipses, which means they heat up dramatically as they approach their closest point, triggering eruptions. 29P doesn't. Its orbit is nearly circular. It stays the same distance from the Sun all year round. That should mean stable, predictable heating and no sudden explosions. And yet, it behaves like a ticking bomb. Why? Why does it erupt so violently when it shouldn't? For years, scientists have tried to find a pattern in its madness. Some noticed that large eruptions often occur roughly every 57 days, matching its rotation period. Could it be that sunlight periodically hits a volatile patch on its surface as it spins? Maybe. But smaller eruptions also occur every 30 or 90 days, too irregular to fit a perfect cycle. It's almost as if the comet has seasons, internal pressure cycles, or hidden fractures deep within. A breakthrough prediction. In April 2023, something extraordinary happened. Astronomers noticed that 29P was dimming its gas emissions, slowing down. They suspected that pressure might be building inside. They made a bold prediction. It's about to erupt. And that same day it did. A small explosion, perfectly timed. It was the first ever successful prediction of an outburst from this chaotic object. For the first time, we weren't just reacting to the randomness, we anticipated it. Science had finally caught up to the madness of 29P. Enter the James Webb Space Telescope. But the real game changer came in 2024. For years, scientists believed that carbon monoxide gas was the primary driver of 29P's eruptions. After all, CO is extremely volatile. It turns from ice to gas even at -248 degrees Celsius. But the James Webb Space Telescope changed everything. Using its near-infrared spectrograph, Webb observed something no one had ever seen before. Not one, but two jets of carbon monoxide, one pointing toward Earth, another toward the north. And in addition to that, Webb detected two separate jets of carbon dioxide, one to the north, one to the south. This was the first definitive detection of CO on 29P. This dual-jet structure suggested something incredible. 29P might not be a single uniform object. It could be a fusion of multiple bodies, stitched together in a slow cosmic collision eons ago. Each fragment might retain different ices, compositions, and internal structures, each capable of erupting independently. That would explain the unpredictability. It's not one volcano, it's dozens, each waiting for its own turn to blow. The amorphous ice hypothesis. But Webb's data also led to a deeper puzzle. Why is there so much carbon monoxide trapped beneath the surface when it should have escaped millions of years ago? Here's one fascinating possibility: amorphous water ice. On Earth, ice is crystalline, its molecules neatly arranged in repeating structures. But in the freezing outer solar system, water freezes differently. At temperatures below 77 Kelvin, -196 degrees Celsius, it forms amorphous ice, a porous, chaotic structure that can trap gases within it. When that ice warms and becomes crystalline, the trapped gases are violently released. If 29P still contains large pockets of amorphous ice, each region could act like a time bomb, waiting for enough warmth to trigger conversion and an eruption. A matter of scale. Here's where size becomes everything. Smaller centaurs, just a few kilometers across, would have long since converted all their amorphous ice into crystalline ice. That process takes only a few million years. But 29P is massive. Models suggest it could take 60 to 100 million years for all its amorphous ice to fully crystallize. At its current location, only about half of it has done so. That means half of its interior is still unstable, full of trapped gas under pressure. Each patch that crystallizes could release sudden jets of CO, cracking the surface, shaking the crust, and hurling debris into space, over and over again. And when parts of the surface collapse back down, sealing the fissures, the cycle begins anew. The chaotic heart of 29P. Some scientists suspect that these structural changes, collapses, sinkholes, and landslides inside the nucleus may be the real engine behind its unpredictable nature. But there's still something missing. Even if crystallization explains the gas, how does the pressure build up so quickly enough to cause multiple eruptions a year? The truth is, we still don't know. 29P refuses to fit into any of our models. It shouldn't behave like this, and yet it does. Perhaps deep beneath its frozen crust, a slow, rhythmic breathing occurs. Pockets of ice melting, refreezing, collapsing again. A kind of heartbeat in the darkness. The cosmic significance. Why does any of this matter? Because 29P might be showing us how the early solar system behaved, when ice, rock, and volatile gases interacted chaotically in the cold frontier beyond Jupiter. Studying it helps us understand planet formation, cryovolcanism, and the strange chemistry that might one day lead to life on other icy worlds. In many ways, Centaur 29P is a living fossil of the solar system's infancy, a frozen relic that still moves, still breathes, still surprises us. And thanks to telescopes like Webb, we're finally peeling back its layers one explosion at a time. The final mystery. Why does it keep erupting? Why so violently, so often, so unpredictably? Every answer only leads to more questions. Is it possible that 29P isn't just a remnant of the past, but a preview of the future, of what will happen when our own icy worlds begin to die, fracture, and vanish into the dark? Perhaps what we're witnessing isn't chaos at all, but transformation. Maybe this is what happens when a world tries to hold on, when trapped energy from the dawn of the solar system still struggles to escape. So what do you think? Is 29P a single unstable comet, or a cluster of icy fragments colliding from within? Could amorphous ice really explain its wild behavior, or is there something even stranger we haven't discovered yet? Let me know what you think in the comments. Because somewhere beyond Jupiter, a lonely world keeps exploding in silence, and no one truly knows why. Thanks for watching. If you enjoyed this deep dive into the mysteries of our solar system, subscribe for more stories that remind us how little we really know about the universe we call home. See you next time under the same silent stars. What if the universe is conscious? A question as old as thought. For as long as humans have looked up at the stars, we have wondered not only what the universe is, but what it might know. Could the cosmos be more than just a stage on which the drama of life unfolds? Could it be the author as well? Could the universe itself possess a form of consciousness? This idea, once relegated to philosophy, mysticism, or science fiction, is increasingly discussed at the edges of modern science. Physicists, neuroscientists, cosmologists, and philosophers are asking, if consciousness emerges from complex systems like brains, could a sufficiently complex universe also be conscious? And if so, what would that even mean? In this documentary, we will explore this breathtaking concept from multiple perspectives: scientific, philosophical, and spiritual. We'll dive into quantum mechanics, panpsychism, cosmology, and theories of information to ask one of the most mind-bending questions imaginable. What if the universe is not just aware of us, but is us? What is consciousness? Before we can ask whether the universe is conscious, we must first understand what consciousness is. Despite centuries of thought, science has yet to provide a universally accepted definition of consciousness. Is it the ability to perceive, to experience, to make decisions? Is it a binary property, or does it exist on a spectrum? Most neuroscientists agree that consciousness involves subjective experience, what it's like to be something. But how that experience arises from matter is one of the deepest mysteries in science. The so-called hard problem of consciousness, coined by philosopher David Chalmers. From neurons firing in a brain to the glow of awareness behind your eyes, something astonishing happens in living minds. But where does it come from? Is it an emergent property of complexity, or is it a fundamental feature of reality? This is where the conversation gets truly cosmic. The rise of panpsychism. One of the most radical and surprisingly popular ideas in recent years is panpsychism, the belief that consciousness is a fundamental and ubiquitous aspect of the universe. According to panpsychism, even elementary particles like electrons may possess proto-consciousness, rudimentary forms of awareness that, when combined in complex systems, give rise to higher forms of consciousness, like our own. Think of it this way: instead of consciousness emerging from dead matter, perhaps matter itself has always had a seed of consciousness within it. Just as atoms combine to form molecules, maybe mind combines to form higher minds. This doesn't mean that rocks or spoons are thinking, but it suggests that the fabric of reality is more like a spectrum of awareness. Panpsychism has been seriously discussed by philosophers like Galen Strawson and even physicists like Roger Penrose. And it opens a door to an even wilder idea. What if the entire universe is a conscious whole? Quantum mechanics and the observer effect. Quantum physics has long been the realm of mystery and paradox, and consciousness seems to sit right at its center. In quantum mechanics, particles exist in superpositions multiple states at once until they are measured. Only then do they collapse into a single state. This is called the observer effect. But what counts as an observer? Does it require a conscious mind, or can any interaction count? Some interpretations suggest that consciousness itself plays a role in determining physical reality. This has led to famous thought experiments like Schrodinger's cat, and to interpretations like the von Neumann-Wigner interpretation, which posits that consciousness is necessary for the collapse of the quantum wave function. If the very structure of reality depends on observation, and if observation depends on consciousness, then maybe the universe requires consciousness to exist at all. Or maybe it is already conscious, constantly observing itself. The universe as a neural network. What if the universe works like a brain? Some physicists and computer scientists have noticed striking similarities between the structure of the observable universe and the neural networks in our brains. For example, a 2020 study found that the cosmic web, the vast network of galaxies and dark matter, resembles the layout of neurons and synapses in the brain. The density, distribution, and connections between nodes show similar patterns. This has led to speculation that the universe could be a kind of giant information processor. Some theories, like those proposed by theoretical physicist Max Tegmark, suggest that reality is mathematics and perhaps computation. Could the universe be thinking? Could we be neurons in a cosmic mind? The anthropic principle and cosmic fine-tuning. Why is the universe so perfectly tuned for life? The anthropic principle states that the universe appears fine-tuned for conscious observers. The fundamental constants: gravity, electromagnetism, The strong and weak nuclear forces seem set just right to allow life to exist. If any of these values were even slightly different, stars wouldn't form, planets wouldn't exist. Life, as we know it, would be impossible. Some see this as evidence of design. Others propose a multiverse, an infinite number of universes with varying parameters. We happen to live in the one where consciousness is possible. But there's another possibility. Maybe consciousness is not a result of the universe, but a requirement for it. Maybe the universe is structured in such a way because it is, on some level, conscious. Consciousness as a field. What if consciousness is not confined to brains, but is a field, like gravity or electromagnetism? This idea is gaining popularity in certain circles. Just as particles interact with the electromagnetic field, maybe all things interact with a consciousness field. Some propose that this field permeates the universe, and that complex systems like brains can tune into it. This might explain why consciousness feels so unified, despite the billions of neurons involved. If this is true, then consciousness is not produced by the brain, but received or filtered by it. This would mean consciousness is everywhere and always has been. The Gaia hypothesis and global mind. Looking closer to home, the Earth itself may be conscious. The Gaia hypothesis, proposed by James Lovelock, suggests that Earth functions as a single living organism, self-regulating and adaptive. Others have extended this idea into the realm of mind, suggesting that human civilization, technology, and communication networks form a kind of planetary brain. Could the internet be the early nervous system of a global mind? Could the Earth itself be awakening? And if that's true for one planet, what about the universe as a whole? The universe awakens. Let's take the leap. If the universe is conscious, what does that mean for us? Are we fragments of its awareness, individual eyes through which it sees itself? Are we co-creators of reality? Or are we just beginning to glimpse a truth too vast to comprehend? Maybe consciousness didn't arise within the universe. Maybe the universe arose within consciousness. This flips the script of science and spirituality. It suggests that consciousness is not the end product of evolution, but the beginning of existence itself. The mystery remains. We may never know for sure whether the universe is conscious, but by asking the question, we touch something profound. In exploring the cosmos, we are also exploring ourselves. The boundary between observer and observed blurs. Perhaps the ultimate discovery is that there is no boundary at all. You are not just in the universe, you are the universe becoming aware of itself. And that changes everything.